نبينا محمد وعلى آله وصحبه أجمعين. This is section 5.7 and it's about inverse trigonometric functions. We mentioned in the previous lecture the definition of the inverse sine function. And we said that y equals sine inverse x if and only if sine y is x, where x is the output of sine, so it's from -1 to 1. Y is the domain of sine, and the domain we chose for sine to be 1 to 1 in that domain is from -π/2 to π/2. So now we need to define the inverse cosine function. Of course, this is the graph of cosine, and as you notice, this function is not 1 to 1 because it does not pass the horizontal line test. The horizontal line test intersects the graph in more than 1 point, so this function is not 1 to 1 and it has no inverse. So we cannot talk about cosine inverse unless we choose a domain in which cosine is 1 to 1 inside that domain. If we want to select the same domain like sine from -π/2 to π/2, we notice that cosine in this domain is not 1 to 1. So we have to select another domain. The domain chosen is from 0 to pi. You can notice that from 0 to pi, cosine is 1 to 1 and it passes the horizontal line test in this domain. So y equals to cosine inverse x means cosine y equals x. X is in the range of cosine, so it's from -1 to 1, and y is in the domain of cosine, and the domain we chose is from 0 to pi. So this is the definition of the inverse cosine function. Notice that this domain from 0, if this is 0 and this is pi, the domain of cosine is here in the first quadrant and in the second quadrant. So if cosine y, if cosine is positive, we are in the first quadrant. So if this x is positive, we are in the first quadrant, sorry. If cosine is negative, we are in the second quadrant. So this is the graph of cosine in this domain from 0 to pi, and the domain here from 0 to pi, the range from -1 to 1. If we switch the graph about the line y equals x, we get the graph of cosine inverse, where the range of cosine would be the domain of cosine inverse, and the domain of cosine would be the range of cosine inverse. So this is the graph of cosine inverse. So how to find values of cosine inverse x? Similar to what we did with sine inverse. First, we call cosine inverse x theta or y, and then we use the definition to write it as cosine theta equals x, and we have to notice that the domain of cosine, which is theta, is from 0 to pi, and then we solve the question. So for example here, find the exact value of cosine inverse of this number. First thing we say, let theta equals cosine inverse -√3/2. So that's the first step. We write cosine inverse theta, and then we use the definition. So the definition says cosine theta would be equal to -√3/2. Now you notice that cosine is negative, and you know that theta is in the domain of cosine, so theta belongs to the interval from 0 to pi. And if you sketch the graph, this means that from 0 to pi, from here to here. But cosine is negative, so theta must be here. This angle would be the angle theta, okay? theta must be in the second quadrant because cosine theta is negative. And now when the hypotenuse is 2, the hypotenuse is 2, so we see that, we find that in this rectangle 30, 60, this is pi over 6, and this is pi over 3. We have 1 here, square root of 3, and 2 here. This is square root of 3 over 2, the cosine. So which angle has cosine square root of 3 over 2? It is pi over 6, because cosine is adjacent over hypotenuse. So this angle theta is pi over 6. Yani cosine, we know that cosine pi over 6 is square root of 3 over 2. Okay, we know that. But what about theta? What is theta? Theta must be in the second quadrant. So the reference angle of theta is pi over 6. So this angle is pi over 6. That's the reference angle. So what is theta? This is pi, which is 6 pi over 6. So pi is, or theta is, 6 pi over 6 minus pi over 6, which is 5 pi over 6. So the answer theta is 5 pi over 6. If you use the calculator, cosine inverse this number, the calculator will give you 5 pi over 6 and not anything else. Only one solution. Theta is 5 pi over 6. Another example, find the exact value of cosine inverse negative half. As usual, let us call cosine inverse negative half theta. And then using the definition, this means that cosine theta is negative half. Again, the cosine is negative, so theta would be in the second quadrant. In the second quadrant. Now, which angle has cosine theta have from this table, from this rectangle, sorry, you see that triangle, from this triangle, you see that cosine pi over 3 is half, okay? So we know that cosine pi over 3 is half, but our angle theta, its cosine is negative half. It is not half. If you remember when we studied reference angles, we said that there are 4 angles with cosine positive or negative half. All of these 4 angles have reference angle pi over 3. So if we are in the second quadrant, then the reference angle, if the reference angle is pi over 3, then this would be the angle theta, because this is 3 pi over 3, so theta is 2 pi over 3, so theta here is 2 pi over 3. And if you use the calculator, this would be the answer. Cosine inverse negative half would be 2 pi over 3. Now, objective 3, sine inverse tangent function. The inverse tangent function. If you graph the equation of tan, y equals tan x, this would be the equation of tan. As you know, tan x is defined to be sine x over cosine x. So whenever cosine x is 0, tan will not be, tan is not defined. And if you remember also this graph, 0, 1, and this is 1, 0, sorry, and here 0, 1, and here negative 1, 0, and here 0, negative 1. And we said that here x is cosine and y is sine. So x is 0 here in pi over 2 and 3 pi over 2. So cosine is 0 at pi over 2. So pi over 2, 3 pi over 2, tan is not defined. And we have a vertical asymptote. This is a vertical asymptote. Also negative pi over 2, negative 3 pi over 2. So tan r is not defined at these points because cosine of these points is 0, and you cannot divide by 0. Okay, if you find tan 0, it is 0, tan pi over 4 is 1, tan negative pi over 4 is negative 1, and then you complete the graph. So this is the graph of tan x. If you look to the graph of tan, the domain of tan is all real numbers except the zeros of cosine, except the zeros of cosine x. Okay, and cosine x would be 0 at pi over 2, this pi over 2 plus n pi. So if you add any multiple of pi, you get 0. So this is the domain of tan, or real numbers, except pi over 2 plus n pi. So you can, n is belongs to z. Z is 0, 1, 2, negative 1, negative 2 integers. Now, as you can notice, this graph is not one-to-one. So as usual, tan is not one-to-one. It has no inverse. To talk about inverse, we have to choose a domain in which tan is one-to-one. What about the domain we chose for sine, from negative pi over 2 to pi over 2? Yes, the function between negative pi over 2 to pi over 2 is one-to-one. But there is only one problem. Tan is not defined at negative pi over 2, and it is not defined at pi over 2. So we chose the domain from negative pi over 2 to pi over 2, but negative pi over 2 and pi over 2 are not included. While for sine, negative pi over 2 and pi over 2 are included. So what is the definition? Y equals tan inverse x means tan y as x. Same definition always, but you need to define x and y. X is the range of tan, and as you can see here, the range of tan, all real numbers. So the range of tan is the set of all real numbers. So we don't have a problem with the range x, but the domain of tan has to be from negative pi over 2 to pi over 2. Remember, from negative pi over 2, this is negative pi over 2 to pi over 2. So this is the domain of tan, either in the first quadrant or in the fourth quadrant, similar to sine x. Let us solve. This is the graph of tan x from negative pi over 2 to pi over 2. We switch this graph about the line y equals x. We get the graph of tan inverse x. Notice here that tan inverse x is always between negative pi over 2 to pi over 2. So the range of tan inverse is from negative pi over 2 to pi over 2, while the domain is all real numbers because the range of tan is all real numbers. So tan inverse cannot exceed pi over 2 and cannot also become lower or smaller than negative pi over 2. How to find the exact value of tan inverse? Same method exactly, but you have to remember that theta here is between negative pi over 2 and pi over 2. Exclusive means negative pi over 2 are not included. Let us solve some examples. Let theta, as usual, equals tan inverse square root of 3. All right, use the definition. Tan theta would be equal to square root of 3. And now you know that theta, that we are talking about tan inverse, so the domain of tan inverse is between negative pi over 2 to pi over 2. So theta has to be in this domain. And you know that from negative pi over 2 to pi over 2, this region, tan is positive, so theta would be in the first quadrant. In the first quadrant, what is the angle with tan equals square root of 3? Again, we need this triangle, 60 or pi over 3, 30 or pi over 6. We know that this is one square root of 3 tan. We know that tan is opposite over adjacent. So which of these angles has opposite over adjacent equals to square root of 3? It is pi over 3. So we know from this triangle that tan pi over 3 is square root of 3. But is theta here pi over 3? Yes, because we are in the first quadrant. So theta is pi over 3. So our answer here is pi over 3, and there is no problem with that. While if the answer is negative, if we want to find tan inverse negative square root of 3, so this would be negative, and then the angle would be in the fourth quadrant, and it would be in this case negative pi over 3 and not pi over 3. Let us find tan inverse of negative 1. Let theta be equal to tan inverse negative 1. Use the definition if and only if tan theta equals negative 1. Now, remember that theta is between negative pi over 2 and pi over 2. It is in the first or the fourth quadrant, but tan is negative, so it should be in the fourth quadrant. Now, what is the angle with tan equals negative 1? If you remember, negative 1 is not in this rectangle, okay? You cannot find tan here negative 1 because 1 over square root of 3 or square root of 3 over 1. So if you remember, you have to use the other rectangle, which is 4 pi over 4. 45, 45 rectangle, pi over 4. Here we know that this is 1, and this is square root of 3. So here, tan pi over 4, tan pi over 4 is 1. Okay, so we have 1. So we know that the reference angle of this theta is pi over 4. But theta has to be in the fourth quadrant. And it has to be from negative pi over 2 to pi over 2. So what is this angle? It is negative pi over 4. The reference angle of negative pi over 4 is pi over 4. So theta here is negative pi over 4. That's the answer if you use the calculator. This is a reminder of the graph of sine inverse, cosine inverse, and tan inverse, and the domain and the range of each of these functions. I leave these questions for you. I think I solved enough examples about tan inverse, cosine inverse, but let me do this one. Let me find tan inverse 0. So as usual, we say let theta equals tan inverse 0. This means that tan theta, by the way, you can call it theta or y, it is no problem. Let me call it here y. So tan y is 0. What is the angle with tan y 0? Where y, remember, y has to be between negative pi over 2 and pi over 2. If tan is 0, you cannot find it from this rectangle, rectangle 45 or rectangle 3060. But which angle has tan 0? If you remember these points, 1 0 0 1 negative 1 0 0 and negative 1, these 4 points will give you the 6 trigonometric functions of any quadrantal angle. And you know that here x is cosine theta and y is sine theta, and tan is sine over cosine. So it's y over x. If you divide 0 over 1, if you divide 0 over 1, you get 0. So from this figure, we find that tan, the angle 0, is 0. But also, this angle, which is pi, tan pi, is also 0. So we have two angles in the first revolution Although if you add revolutions, if you add 2 pi, you will get also 0. So tan 0 is 0, tan pi is 0, tan 2 pi is 0, tan 3 pi is 0, tan 4 pi is 0. All of these zeros. So which one here? What is tan inverse of 0? You cannot say all of these. You need one of them between negative pi over 2 to pi over 2, and the only one between negative pi over 2 to pi over 2 is the 0. So tan inverse 0 is 0. That's the answer of this question. Please do this one similarly. And let us now go to the calculator. How to use the calculator to evaluate the inverse trigonometric functions. Use a calculator to find the value of 4 decimal places of each function. Let us do it together. Let us go. Now, sine inverse 1 over 4. What would you like your answer? Would you like to have it in degree or in radian? So I'll always, he did not say here anything. So I will use radian. So shift mode and make sure that you are in radian mode and ask sine inverse. You have sine inverse above the sign. You need to use shift sign. So this you will see sine inverse and write 1 over 4 and ask for the answer. So the answer is 0.25268. So I'll make it 7 because he asked it for 4 decimal places. So this is in radian mode. What about tan inverse? The same, just use tan inverse and write negative 9.65. So the answer would be negative 1.4675, and after 5 I have 3, so that's the answer to 4 decimal places. Please use the calculator to find cosine inverse of 1 over 3 and tan inverse of negative 35.85. Now, in real number mode, most calculators will display an error message. Okay, he said here, I attempt to evaluate an inverse trigonometric function at a value that's not in the domain. Okay, so if you want to find inverse trigonometric value that's not in the domain, for example, cosine inverse 3. Well, we know that the domain of cosine inverse is the range of cosine, which is from negative 1 to 1. So you have to ask the calculator for cosine inverse a number between negative 1 and 1. If you ask the calculator for cosine inverse 3, the calculator will say math error. Okay, so you will know that 3 is not in the domain of cosine inverse. Now, let us solve these exercises. Use a calculator to evaluate this. Let us check sine inverse negative 0.32. Round to 2 decimal places. So the answer is negative 0.33 because 25, so I write it 3. Cosine inverse cosine inverse square root of 5 over 7. Okay, the answer is 1.245, so I make it 5, and so on. Please try this one. Okay, find exact values of composite functions with inverse trigonometric functions. This is very important, and please pay attention. We know that if circle f inverse of x is x, and f inverse circle f of x is x. But this formula works only if x is in the domain of f inverse, because x has to be in the input of f inverse. X must be in the domain of f inverse here. And here, x must be in the domain of f, okay, for this to be true. So when you say sine inverse of x equals x, you have to understand that x here must be in the domain of sine inverse. And the domain of sine inverse is the range of sine, which is from negative 1 to 1. So this formula only works if x is between negative 1 and 1. So if you say sine inverse 2, for example, it doesn't work. The answer is not going to be 2. Okay, for the answer to be x, the number has to be between -1 and 1. Also here, you have to notice that x must be in the domain of sine, and you have to remember that the domain of sine is from -π/2 to π/2. Same for cosine, here from -1 to 1, and here from 0 to pi. Same for tan, here for any real number, because the domain of tan inverse is the range of tan, and the range of tan set of all real numbers. And here the domain of tan, if you remember, from -π/2 to π/2. So these formulas are true only in these intervals. So you have to know that. For example, if you use the calculator to find this answer, cosine inverse 0.6. Now, uh, what is the domain of cosine inverse? Okay, domain of cosine inverse is the range of cosine, and it is from -1 to 1. 0.6 belongs to -1 to 1, so the answer would be 0.6. So you have to tell him that why the answer is 0.6, because of this. Use the calculator, the answer would be 0.6. Let us look here. Now, what is the domain of sine? Okay, we know that the domain of sine that we chose from -π/2 to π/2. Now, is 3π/2 in this domain? No. So the answer here is not going to be 3π/2. So how to find the answer for this question? Now, this is π/2. Okay, and this is -π/2, and also it is 3π/2. So here, if you go in the positive direction, this is 3π/2. Okay, and in the negative direction, this is also -π/2. So we can say that sine inverse sine 3π/2 is equal to sine inverse sine -π/2. Why -π/2? Because -π/2 and 3π/2 are coterminal. Coterminal, they have the same terminal side. So their 6 trigonometric functions would be equal. So sine 3π/2 would be equal to sine -π/2. And why -π/2? Because -π/2 belongs to the domain. So the answer now would be -π/2, because -π/2 belongs to the domain from -π/2 to π/2. So if you use the calculator, if you write in the calculator sine inverse sine 3π/2, you will find that the answer is -π/2, and it is not 3π/2. Now, what about cosine inverse 1.5? You have first to ask yourself about cosine inverse. What is the domain of cosine inverse? It is the range of cosine. What is the range of cosine? It's from -1 to 1. So is this number from -1 to 1? No. 1.5 does not belong. Please close the mic. 1.5 does not belong to this interval from -1 to 1. Okay, so can I find another function, cosine inverse, with another number that's equal to this? Can I do what I did here? And the answer is no, I can't, because cosine inverse 1.5 is just one number, because cosine inverse is 1 to 1, but sine is not 1 to 1 in general. Okay, so how can I do this? Cosine inverse is not defined. This is not defined. If you use the calculator will say math error. I cannot find cosine inverse of 1.5 because the number here has to be from -1 to 1. But if you have sine inverse sine, then you can replace sine 3π/2 by sine another angle, because sine is not 1 to 1 in general. Please try to solve this one and this one, okay, using the same method. This one also similar. This number is greater than -1, so this is not defined actually. Similarly, not defined because domain of cosine inverse should be the range of cosine should be from -1 to 1, and -1.2 does not belong to the domain, so this is not defined. Try to do this one. Okay, let me do this one for you. 39 tan inverse tan negative pi over 6. I have to consider the domain of tan. What is the domain of tan? If you remember, the domain of tan is from negative pi over 2 to pi over 2 exclusive, okay, like this. Is negative pi over 6 here? Yes. So the answer would be negative pi over 6 because negative pi over 6 belongs to this domain from negative pi over 2 to pi over 2, and you can check your calculator also, it will give you the same answer. While here, now look to this one, tan inverse tan 2 pi over 3. 2 pi over 3 is not in this interval, which is from negative pi over 2 to pi over 2. Okay, so let us sketch the graph. Maybe we will understand. Okay, negative pi over 2 here, 2 pi over 2 here. This is the domain in which tan is defined. Now, where is 2 pi over 3? 2 pi over 3 is, this is 3 pi over 3, so 2 pi over 3 is here. Now, this angle is not in the domain, so the answer is not 2 pi over 3. What can you do? You can write tan again. You can find another angle that has the same tan as 2 pi over 3, and it should be in this interval. Okay, ask yourself, here in this quadrant, is tan positive or negative? In this quadrant, tan is negative. So the angle you need to find should be here in this quadrant, in the fourth quadrant, because here also tan is negative. How to find the angle you need in the fourth quadrant? You find the reference angle. What is the reference angle to 2 pi over 3? It is pi over 3. So I need an angle with the reference angle equals to 2 pi over 3. Sorry, pi over 3. So the angle should be pi over 3. What is this angle with reference angle pi over 3, but in the negative direction? It is negative pi over 3. So if you go to in the negative direction, the angle is negative pi over 3. So tan negative pi over 3 is equal to tan 2 pi over 3 because they are in a quadrant in which tan is negative and they have the same reference angle. So this is correct. Now, since negative pi over 3 is in this domain, the answer would be negative pi over 3, and that's the answer that would be given by the calculator, because negative pi over 3 in this domain. Please try this one, 34, and also for 45. I will stop here. There will be, inshallah, another small part of this section, but that's enough for today. Thank you very much.